Hello friends, greetings to all. I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for the subject head Network Theory. So friends, as far as this today's session is concerned, so we will try to discuss this another circuit analysis technique whose name is nothing but the Norton's Theorem. So friends, with the help of one very simple example or a basic example, we will try to learn how this Norton's theorem strategy is being used in case of this electrical engineering for the purpose of circuit analysis. As I told you earlier, circuit analysis in the sense whenever we are interested to determine the ohmic drop or the desired current flowing through any particular branch, at that time we are in need of the circuit analysis technique. So first of all, we need to understand the basic statement of this Norton's theorem. So basically, this Norton's theorem states that in case of any two-terminal linear bilateral network or linear bilateral circuit, as we know, linear bilateral means what? The circuit parameter will remain unchanged irrespective of any voltage or current change which is applied to that circuitry. So, in case of any two-terminal linear bilateral network, that particular circuit can be replaced with this equivalent Norton's circuit, which consists of two important parameters. One is current source and another is nothing but what? The resistance which is connected in parallel form or the resistance which is connected in shunt form. So this Norton's theorem states that any linear two-terminal bilateral circuit can be converted into the equivalent Norton circuit, which consists of this Norton's current source and the Norton's resistance, which is connected in parallel form. And here we used to have our target resistance, that is nothing but what? Load resistance R here. So the name given to this current source is nothing but what? I suffix of SC, and this is nothing but what? R suffix of N. Or another name given to this current source is nothing but what? I suffix N. So basically I suffix N or I suffix SC stands for what? The short circuited current or the Norton's current. So first of all, we need to understand how to tabulate this Norton's current. Then after that we will try to discuss how we are getting this Norton's resistance. So these two are the important parameters of this Norton circuit, which consist of the Norton's current and the resistance is connected in shunt form along with this Norton's current source. And after that we are connecting the target resistance. So as far as this existing network is concerned, okay friends, welcome back. So in this existing network, our objective is to we are supposed to determine the desired current flowing through this 5 ohm of resistor. So this is how our test circuit will look like, which consists of finite number of energy sources as well as the resistive arms we used to have with us. So in that circuitry, our target resistor is this 5 ohm of resistor. We are supposed to determine the current flowing through this 5 ohm of resistor by using this Norton's theorem. So according to the statement of this Norton's theorem, as I told you earlier, any two-terminal linear bilateral network can be converted into the Norton's equivalent circuit, which consists of this Norton's current and Norton's resistance. Now we need to understand the design steps which involves in case of this Norton's theorem. What kind of design strategy we need to follow in order to convert this existing network into the Norton's equivalent circuit. So we will discuss the design steps for this Norton's theorem. By means of that design step, we can convert this existing network into the Norton's equivalent circuit. So in that first step, this is how our circuit will look like, right? So in that circuit, this is our target resistance of 5 ohm. So in that first step, we need to replace this target resistance with one short circuited arm denoted by these two terminals A and B. Means in that first step itself, the target resistance is being replaced with this short circuited arm, and the desired current flowing through the short circuited arm, that can be called it as a Norton's current, or another name given to that current is nothing but what? The short circuited current. So in that first step, one more time we need to redraw the circuit. This is our battery of 30 volt. This is 5 ohm of resistor. This is 5 ohm of resistor 2. Then this vertical arm consists of resistor of 10 ohm here in this way, and these two are the adjoining resistors 4 ohm and 6 ohm. And as far as this target resistance is concerned, so this target resistance is replaced with these two short circuited terminals A and B, and the current flowing through this particular branch is nothing but what? ISC. So our target is to determine this short circuited current. So in order to determine the short circuited current, there are a number of different techniques. By means of that we can determine the short circuited current. The short circuited current is nothing but what? The current flowing through this 4 ohm of resistor or 6 ohm of resistor. So by means of mesh analysis or by means of nodal analysis also, we can determine this particular short circuited current, but we will try to adopt the easiest strategy. So by resolving the circuitry, means by knowing the series and parallel combination of existing resistors, also we can determine the I short circuited or the short circuited current. So for that purpose we need to resolve this circuit. Resolve in the sense we need to find out how the resistors are interconnected with each other, right? So as far as this existing circuit is concerned, the battery is of 30 volt. This 5 ohm and 5 ohm, these two resistors are connected in series form, obviously. So this 5 plus 5 10 ohm resistor is connected in shunt with this 10 ohm of resistor, right? At the same time, this 4 and 6 ohm resistor, these two resistors are connected in series form. So these two resistors are being added. So this is how that circuit will look like. This will be the 30 volt of battery. This 5 plus 5 10 ohm of resistor. This is vertical arm of 10 ohm, and again these two resistors are being added along with this short circuited branch. So again 6 plus 4 it will become 10, and here we used to have the short circuited branch A and B. So we are interested to determine this ISC, right? So by means of nodal analysis also or by means of loop analysis also we can determine this ISC, but we will try to adopt the easiest strategy. So we are coming on to this conclusion कि this 10 ohm, right? This 10 ohm, this 5 plus 5 10 ohm, it will become 10 ohm. Then after that obviously this 10 ohm of resistor is connected in shunt with this 10 ohm of resistor, right? So according to this parallel combination, its equivalent resistance will become what? R1 R2 divided by R1 plus R2, right? R1 R2 divided by R1 plus R2. So 10 into 10, obviously it will become 100. 100 divided by 10 plus 10, 20. So 25 is a 100. So it will become 5. So total resistance will become what here? 15. So how our circuit will look like? Here I will draw. Here I will draw. This is how many volt of battery? This is 30 volt of battery, and finally the resistance is how many ohm? 15 ohm, and this is A and this is B, right? So here what we need to do, first of all we need to determine the total current due to this 30 volt of battery. So according to that Ohm's law, I equals to V by R. So here V equals to 30 and R equals to total resistance 15. So 15 to the 30, 2 ampere. 2 ampere is nothing but what? The total current up to this point. And we are interested to determine this I short circuited current, means the current flowing through this particular branch, right? So for that purpose, by using the current divider rule, we can determine the IS here. Okay friends, so after getting the total current due to this 30 volt of battery, which exactly equals to 2 ampere, by resolving that circuitry by using that series parallel combination, then our area of interest is to determine this I short circuited or the current flowing through this 10 ohm of resistor. So as we are knowing that up to this particular node, the total current due to this 30 volt of battery is exactly equals to 2 ampere. So the tendency of that current is to get divided in between these two branches, because these two branches are connected in shunt form. So at this particular node, we need to use the current divider rule. So according to this current divider rule, we are interested to determine this ISC, or we can call it as a current flowing through this 10 ohm of resistor, right? So according to this current divider rule, up to that node, total current is of 2 ampere. So total current multiplied by the resistance in its opposite arm. So in its opposite arm, we used to have the resistor of 10 ohm. So 2 into 10 divided by summation of all these two resistances. So 20. So it will become 10 to the 40 divided by 20. Sorry, 10 to the 20 divided by 20. So 1 ampere. 1 ampere is nothing but what? The short circuited current. The first parameter of this Norton's equivalent circuit. As I told you earlier, Norton's equivalent circuit consists of the short circuited current and this Norton's resistance. The Norton's current and the Norton's resistance. Okay friends, so after tabulating this short circuited current, then after that we need to determine the Norton's resistance. So the way in which we have tabulated the Thevenin equivalent resistance, in same manner the Norton's resistance is to be determined. In order to determine this Norton's resistance, first of all we need to understand the Norton's resistance is nothing but what? The equivalent resistance of that network which is to be observed from this short circuited terminal as a result of replacement. This load resistance is replaced with these two short circuited terminal A and B. So the equivalent resistance of that circuit which is to be observed from this short circuited terminal is nothing but what? The Norton's resistance. So while tabulating this Norton's resistance, if we are having the voltage source, so that can be treated as a short circuited terminal. If we are having the current source, so that can be treated as an open circuit terminal. So as we are having only one voltage source in that network which is of 30 volt, so it is being short circuited like this. Once it is being short circuited, so we need to observe the resistance from this particular end. So from sake of observation, we are coming on to this conclusion key, as these two resistors are connected in series form, 5 plus 5 10. Okay friends, so as I told you earlier, these two resistances are connected in series form, so it will become 10. This 10 ohm of resistor is connected in parallel with this 10 ohm of resistor, right? The summation of these two resistors 5 plus 5 10 is connected in shunt with this 10 ohm of resistor, because this 10 ohm of resistor is connected in vertical arm. So 10 parallel to 10, half of that 5 ohm, and furtherly this 5 ohm is connected in series with this 6 plus 4 10 ohm of resistor. So the Norton's resistance equals to how many ohm? The Norton's resistance equals to 15 ohm. So in this way we are having two parameters, the I short circuited and the Norton's current, or the Norton's current and the Norton's resistance. So here the Norton's current equals to how many ampere? Norton's current equals to 1 ampere. Norton's resistance equals to 15 ohm, and our load resistance is nothing but what? The load resistance is of how many ohm? The load resistance is of 5 ohm. And what we need to determine? We need to determine the current flowing through this 5 ohm of resistor. So finally what we need to do, once we are having the Norton's equivalent circuit according to this Norton's theorem, any two terminal linear bilateral network can be converted into this kind of Norton's equivalent circuit, which consists of this Norton's current and Norton's resistance. This Norton's resistance is connected in shunt form with this current source, right? And again one more load resistance which is connected in shunt form with this Norton's equivalent circuit. The resistance value is of 5 ohm. So up to this node the total current is how much? Up to this node total current is 1 ampere, and the current flowing through this 5 ohm resistor equals to what? The total current 1 ampere multiplied by resistance in its opposite arm, that is nothing but what? 15 divided by 15 plus 5. So it will become 15 by 20 ampere, right? So this will be the desired current flowing through this 5 ohm of resistor by using this Norton's theorem principle. So I just hope you had understand all these things belongs to this Norton's theorem. Simply any two terminal linear bilateral network can be converted into Norton's equivalent circuit, that we need to remember, which consists of Norton's current and Norton's resistance. How we are getting the Norton's current? By replacing the target resistance with this short circuited terminal abbreviated as A and B. And from that short circuited terminal we need to observe the equivalent resistance of that circuitry, that can be called as a Norton's resistance. So I just hope you had understand all these things regarding to this Norton's theorem. Thank you, and do not forget to subscribe my channel. Thank you.